Hello everyone, we are going to start our lesson today, and today's topic is density, and this is our 8th grade science class, and today we are going to learn about a topic which is called density, and it has a reference from the earlier one which we have studied about the mass, the volume, and the distance and all those things, and we are going to correlate everything in this topic. Okay, so the goal of this lesson, we are going to define what is density, and we are going to identify the different properties of density, and then lastly we will identify the relationship between the density variables. Okay, now we can see the two different pieces of land, and the size and shape of both the lands is same, but here is a difference. What difference we can see in that? In the upper one, the first one, there are so many plants in that, very tightly packed, and the other one, there are less number of plants which are like little far away from each other, and we can see the more number of land. So what is the relationship between these two? And that is, we are going to make that thing understand what is the how it is related to the density. Okay, next. So now mass, volume and density. Mass and volume are the physical properties. Together they are used to find the density of an object. What is volume and the space? We can see the space over here. This is a volume. The more the space, more the volume. Less the space, less the volume. Okay, now what is mass? Mass means in this space the objects. So we can see there are a couple of round things in here, the 6 round balls things are here. So these are the objects. So in this space, more the object, and the space is same, more the density. Okay, so I just told you ahead of time like what is a density. So here these things inside this space, these balls inside this space, they are the mass, and this, the amount of this space over here which is covered, that is a volume. Okay, next, what is density? Density is a comparison of how much matter there is in a certain amount of space. The amount of matter per unit of space. Like in a given space, how much the matter is. Is it less or is it more? Then that amount is called a density. Okay. More matter in less space, that is more dense. In a space, like if the space, if we have a space this much and this much space is packed tightly, that means it is going to be more dense. And the same space, if it is packed very loosely, that is less dense. Okay, now less matter in more space, that is also less dense. So we got what is the meaning of more dense and less dense? More dense in less space, like more stuff in a less space, that is more dense, and less stuff in more space, that is less dense. Okay, now let's do it little more elaborate. We can see this city. This is an aerial view of a city, and we can see there are everything we can see, like which are the very far off places, or the cars or the objects, everything which has been seen from the air view. This is looking like the city is very crowded, it is very dense. We can see very less empty space or the land in here. That means the more the matter, it is tightly packed, that means it is very dense. Okay, now let's do a little more about that. Okay, now in this diagram there are two boxes given here. In one box the space is same in both of these boxes. In the first box there are like just 5 circles, and in the second box there are so many circles. So we will see which one has more density, that means which has more stuff in it. The space is same for both, so the second one, of course the second one is more dense and the first one is less dense. Okay, I think you guys have completely understood this, why more matter the same space. Okay, now Now here in this, which one is more dense? Now the first box is very small, like less space, and the second one is big, that means more space. So less space, more space. In less space we have the and more space we have the same amount of matter. Here also are the 5 circles, and here also 5 circles. So these 5 circles are been packed in a very small space, and these 5 circles are been placed in a long space. That means the density of the first one is more because it is tightly packed. So the main idea, what is density? Density, the more tightly packed is more dense. Okay, all right. Now we are going to look at this mathematically. Okay, this is, of course, it's a more dense and this is less dense. Why? Same matters and less space. Now we will going to try it. How do I make the front of the classroom more dense and less dense? In the front of the classroom, if we have, I think you will be able to tell me, if I will call all students to the front, that means the front of the room will become dense, and less dense, okay, I will say, okay, all of you go to the back of the room and only 2 or 3 students will be standing in the front. So that is less dense. Okay, all right. Thinking like a college scholar, now we are going to elaborate this definition. What is density? Like in a claim, evidence, and reason. I'm going to explain you what is claim, evidence, and reasoning like a scholar. Okay, claim. Claim means level 1 response, stating the answer in a complete sentence. No proof is required, just the answer. Okay. Evidence. State the evidence in sentence form. What is your proof? Your data. You are going to say, what is the proof? Like, why did you set that answer? Why did you completed the sentences? And what is your data? And reason. Now you will be giving the reason. Answer the question. How do you know? Contain your claims and evidence and explain them. Show you understood the question. Okay, all right. Now we are going to take an example. Now here these are the two towns. One is a Waterloo plan. Waterloo. The population is 99,000, and the both towns take are 500,000 square feet. The area is same. Which one is more dense and why? So here we can see the claim, the city of Waterloo is more dense. Why? Because the area is same for both, and the population in Waterloo city is 99,000. Okay, evidence. Both cities take up the same amount of space, but the Waterloo has more people in that space. And the reason, what is the reason? Reasoning. An object that is more dense has more matter per unit of space. Waterloo has over 98,000 more people tightly packed into the same amount of space. Therefore, Waterloo is more dense than Montclair. Okay. Now, second example. One elevator is 20 square feet and another elevator is 10 square feet. They both have 8 people in them. Which is more dense? I think you guys have understood. Claim is elevator 2 is more dense. Evidence. Elevator 2 has the same amount of people in a smaller amount of space, so the matter is more tightly packed. And now, what is the reason for that? The more tightly packed together matter is, the more dense the object is. In elevator 2, there is the same amount of matter in a small space, therefore the elevator 2 is more dense. Okay, now next, little more. Which is more dense? So, claim cylinder 2 is more dense. As we can see that the red dots are more in cylinder 2 and they're less in cylinder 1. And evidence, the amount of matter is tightly packed than cylinder 1, and there is more matter in the same amount of space. So we can see both the cylinders are of the same size, and but here they are very tightly packed and they are very loosely packed. And then now what is the reason for that? So the reason is that that is more dense. Density is the amount of matter, like amount of these red dots per unit space. So per unit of space, he is more. And since the cylinder 2 has more matter in the same amount of space, it is more dense. So that is the reason for cylinder 2 being heavier density, more density. Okay, now next. Now you will see what is the density of matter. Now here we are taking an example of, just think that this is water. So water in a gas form, and water in a liquid form, and water in a solid form. How tightly packed the matter is the amount of mass in a given space. So we can see the space is same, the amount of space, these squares are the same size in all the three pictures. In the first one, they are the gases, they are very loosely packed, and in the liquid they are like little more densely packed, and here are very much tightly and very much densely packed. That's why it's a solid. They don't have a space to move on, they have a very little space to move on, and they have a lot of space. So they have a lot of space, that means they're very little less dense, and then the solids are most dense, and liquid are just dense, more dense than the gases. So this is how we can compare. We see the less the density, lower the number of density, lower the number, that is the lesser the density, and higher the number, that is the more the density. Okay, all right. Next, here we are coming to go to the calculation, that is the mathematical part. Density, so here is a formula for density, mass divided by volume, and in short we write down D stands for density, M stands for mass, and V is for volume. So D equals mass divided by volume. Okay, now we will be going on the mathematical part of that, calculation of the density. And sometimes we forget, like what is the formula, we forget. So we have a trick. What is the density? We are going to know about that trick and learn about that trick a little later. And now here, the ratio of mass to volume and the amount of matter per unit of space. What is matter? It is a mass. Okay, amount of matter per unit of space. So the matter is mass, and per means division, per, that is divide, and the space means space is a volume. So mass divided by volume. This is one way to remember the formula. Okay, now here we got this. Another trick to remember the formula is we will draw a triangle on our sketch paper, and then we will draw one T inside it, and we will write down DMV. DMV is a D comes at the bottom, and M goes on the top and V on the side. So D and V on the side by side, and M is on the top. And from here we will find out the density. Okay, if we need to find out D, what is D equals to? We are going to hide D. So this is D equals M divided by V. And then if we want to find out V, we are going to hide V, and that is M divided by D. And if we want to find out M, how much is the mass? So these are the two side by side. So we are going to multiply D and V. That is density multiplied by volume is equal to the mass. Okay. Next, always remember the units. So density is mass divided by volume, or mass divided by volume. The unit of density is gram per centimeter cube, and the another unit is gram per ml. So here we have, if it is a centimeter cube, that means it is a solid, that object is a solid. If it is ml, that means the object is a liquid or gas, it's a fluid. Why are these units for the density? Okay, now we will see what are the steps of calculating the density. Step number 1, always write on the equation like we got it from our triangle. Number 2, label them. Number 3, plug in and solve it. Okay, now we will be solving one of the problem. Frank has a paper clip. It has a mass of 9 gram and a volume of 3 centimeter cube. What is its density? So this is the formula. Here we have the number, mass is 9 and volume is 3 centimeter cube, and then we have divided 9 divided by 3, and we got 3. Density is 3 gram per cubic centimeter. So this is one of the example. Another example is he has an eraser. Frank